In our previous video, we explored the output and transfer characteristics of the IGBT, showing how the collector current changes with both the gate emitter voltage and the collector emitter voltage. If you haven't seen that video yet, click the link on the screen or check the description below to watch it. It'll give you the foundational knowledge you need for today's topic. Now let's focus on the switching characteristics of an IGBT, how it behaves when turning on and off. Picture two waveforms on the screen. The top one is the gate emitter voltage, VGE, which acts as the control signal. The bottom waveform shows the collector emitter voltage, VCE, and the collector current, IC. These reveal the actual switching action. Starting with the turn-on process. When VGE rises and crosses the gate emitter threshold voltage, the IGBT begins to conduct. There's a short delay here called the turn-on delay time, or TDN. VGE has risen, but the collector current hasn't started to increase just yet. Then, the current ramps up, and the collector emitter voltage drops. The time it takes for IC to go from 10% to 90% of its final value is called the rise time, or TR. Add the delay and rise time, and you get the total turn-on time, T-on. For turning off, when VGE drops, the IGBT starts to turn off. Again, there's a delay, the turn-off delay, or TDF, where current still flows even as the gate voltage falls. Then the current drops, sometimes in two stages, t𝒹1 and t𝒹2, depending on your circuit. As current decreases, VCE rises back toward VCC. Turn-off time, T-off, is the sum of the delay and fall times. Understanding these switching parameters is crucial for designing high-speed or high-frequency IGBT circuits. Think inverters, motor drives, or power converters. Faster transitions mean less switching loss and better efficiency. To sum up, switching characteristics define how quickly and efficiently an IGBT changes states. Mastering this lets you optimize performance and minimize energy loss in real-world designs. If you missed our earlier breakdown, check it out using the link or the description. If you found this helpful, like and share, and subscribe. Got questions or want to see a simulation? Drop a comment below, I'm happy to help.